Tonight we're going to be talking about exponential models, and I'm going to just go ahead and get right into it. We're in section 7.1, and just follow along with me and fill in the blanks where I fill in the blanks. The general form of an exponential function is y equals a times b to the x, and I want you to pay close attention here. The variable in this equation is up here in the exponent. That's what makes it an exponential function, when the variable is in the exponent. Now a is the initial amount. You'll learn more about what all this stuff means, but a is the initial amount and b is the growth factor or decay factor. So this is an important relationship. B is going to be equal to 1 plus r, where r is the constant rate of growth or decay, and if r is a rate of growth, then r would be positive, and if r is a rate of decay, then r would be negative. By the way, I want you to give me some feedback on how light the images are here. I'm experimenting with a new light, so I'd like to get your feedback. Therefore, if b is greater than 1, the function models growth, or the y values keep getting bigger, and if b is between 0 and 1, the function models what we call decay. So when you see, like it says here, when you see words like increase or appreciation, you want to think growth. And when you see words like decrease or depreciation, you want to think decay. And for an exponential function, the y-intercept, so we're always wanting to find y-intercepts, easy to find, it's always the value of a. And again, the exponential growth or decay function is y equals a times b raised to the x power. And this is not a and b being raised to the x power, it's a being raised to the first power and b being raised to the x power. So in this next section of problems here, we want to determine whether or not the function represents growth or decay. So are the numbers getting bigger? Are the y values getting bigger, or are they getting smaller? And remember, when you look back at that a, when you look at the b value, let me write that right here. B again is 1 plus r. So if r is positive, so we want to think about this. If r is positive, then b is greater than 1. So that's the key right there, is b greater than 1. So if b is greater than 1, then we have growth. If r is negative, then b is less than 1, and therefore we have decay. So I wrote that right over those words as well. So the numbers are getting smaller when b is less than 1, the numbers are getting bigger when b is greater than 1. Okay, so when you look at this equation, y equals 8,000 times 1.15 to the x, that right there is your a value. That guy right there is your b value, and clearly b is greater than 1, and if b is greater than 1, we have growth. That's it. That's all you have to do. And here, again, the number that's being raised to the x power, if that's less than 1, then we have decay. That's all there is to it. And you might think, well, why is that? Okay, well, we'll get to that. Let's look down here at number 3. Number 3, we clearly see here that b is less than 1, and raising a number less than 1 to the x power means that we're going to have decay. And let's stop for a moment and talk about that. If you raise 1/2 to the first power, well, that's 1/2. And then the next number, if you raise 1/2 to the second power, think about what that does. If you square a number, normally the number gets bigger, but again, when the number is less than 1 and you square it, look what happens. You get a smaller number. So squaring a number less than 1 means you're going to get a smaller number. That means the y values, as the exponent gets bigger, 1, 2, and then let's even do 3, 1/3 to the third power is 1/8. So as the x value, the exponent gets bigger, then the number that's being raised to the power gets smaller. And therefore that number keeps being multiplied by that first number, which basically means that the y values continue to get smaller and smaller and smaller as long as the b value is less than 1. And the same holds true when b is greater than 1. When you keep squaring or you keep raising a number bigger than 1 to a power, you see that the y values continue to increase, which creates growth. So let's look at how this works. And in fact, we're going to look at how this works in the next example, this example here, in the next video. So we'll be right back.